So hi and hello. Welcome to our channel named AlgoXploration. My name is Samir. Now in this lecture we are going to see the famous problem called as rainwater trapping problem. So here we have given an array. Now this elements or these values represent the height of the building. Okay. So if we talk about this two represents the height of the building will be 2. So if we represent graphically, the array will look like this. Now here we can see that the elements are 0, 1, 0, 2. So 0, 1, 0, 2. Now if we talk about this bar, it is nothing but the height of this building is 2. Now the question is saying that we want to find out the total number of water that will be trapped inside this top of the building. Okay. Now if we see this, here the water can be trapped. Here also the water can be trapped. Here also as well as here also. So we have to return the total blocks of water that will be trapped. Now, now here we can see that in this section the water has been trapped, right? So here one block of water has been trapped. Here one, here two, here one, and here one. So we can see that total 6 blocks of water has been trapped. So we have to return this 6. Okay. Now let's see that how we can solve this problem. But let me tell you that we have started a series on DSA problem. If you know the fundamentals of DSA but getting stuck while solving the DSA problem, this series will be helpful for you. If you are preparing for placement and interviews, you can visit to this playlist. The link is in the description box. Thank you. Now, first of all, we have to figure it out which building can hold the water on its top, right? So if we say, okay, this is a single building, now we can see that this building can't hold the water on its top because if the water falls, it will just flow away, right? So this building cannot hold the water. Let's talk about this building. Here also we can see that these are the two buildings. Okay, one is slightly higher than the second one. Now these buildings also cannot hold the water because if the water falls on the top of it, it will simply flow away to this, right? Now what if here we can see that this building can hold the water, right? So here we can hold the water because if we talk about this building, on the left side there is a building which has higher height. Also there is a building on its right side which has higher height, right? So this building can hold the water. So if we see this type of pattern, okay, then we can say that these buildings can hold the water. So here also we can see that if we talk about this building which has height 0, on the left hand side this building which has height 1, also there is one building also which has height 2. Also on the right hand side there is also one building of height 3. So this building which has height 0 can hold the water of 2, right? So we have to see this type of pattern to hold the water. Now let's see which building can hold the water. So this will not hold the water. This will also not hold the water. This building can hold the water, the height of 0, because on the left hand side there is one building present of height 1. On the right hand side there is building 2. There is one building with height 2 is present. So this building can hold the water on its top. Again, this building cannot hold the water. This building can hold the water. This building can hold the water as well as this building can hold the water. Now if you see for building 3, the height is 3. Now this building is actually the highest of all, right? And we can see that if this building will not hold the water because if the water comes, it will simply flow away, right? So this building cannot hold the water, nor this building, but this building can hold the water. Why? Because we are talking about this building. Now if the water comes, it will store because on the left hand side there is this building of height 2. Also on the right hand side there is this building of height 2. So due to that, this building can hold the water. What about this height 2? this building will not hold the water, nor this building. Okay, so till this point we know which buildings can hold the water. Now the second point is that we want to find out how much blocks of water that building is going to store, or let's say trap. If you see this pattern, here the water is going to log, or let's say trap. Now we have to figure it out. Let's say if we are standing on ith building, we have to find out on its left side whether a building is present with height greater than ith building or not. Similarly, we have to find out on its right whether the building present with height greater than ith building or not. If we found out, then we can simply say that this building can hold the water. So if we are going to talk about this building, the thing is that we have to traverse on its left side, checking for which building having highest height. Okay, we can see that this building has the height of 2. Also, we have to traverse on the right hand side, searching for which building has the greater height, right? So we can see that this building has the height of 3. So this and this, right? We have to figure it out how much block of water this building can store, right? Now since the height of this building is 0, we can store minimum of 2 or 3, right? We can't store block 3, because if you store block 3, if you store 3 blocks of water above this, then it will simply flow away because there is a path, right? So we have to store the minimum of these two. So the minimum of 2 and 3 is 2, so we are going to simply store 2 blocks of water. I hope you got this. So if we are standing on the ith building, we have to traverse it on the left. So the for loop will look like this: for I k is equals to I minus 1. Okay, we are traversing on its left. We have to go till 0. Then we have to search for the maximum height of the building on its left. So the max left is equals to math dot max of max left comma a of k, right? Using this for loop, we are able to find the maximum height of the building on its left. Similarly, we have to find the maximum height of the building on its right. So here also we are going to take the help of the kth variable, and it will start from I plus 1 and it will go until n minus 1, right? Max right is equals to math dot max max right comma a of k, right? Using these two for loop, we are able to find for every ith building that what is the max left as well as max right. Since we are finding for every ith building, for this building we will get max left as well as max right. For this building also max left as well as max right. Now the thing is, since we got it, now we have to figure it out how much blocks of water this will store. Now if we talk about this building, the max left is 2 and max right is 3, right? Now we have to find the minimum of it. So minimum will be 2, right? So the thing is that 2 blocks of water will get stored here, right? But let's talk about this building. Now for this, now for this, the max left is 2 and the max right is 3, right? Now the minimum of this is 2, right? But we can't store 2 blocks of water. We can see that it is actually storing only 1 blocks of water. Why? Because here the height of this building is 1. So we can store only 1 blocks of water. So the formula will be, first of all, we have to find the minimum of max left and max right, right? and we have to subtract it with the height of the ith building. Okay, so in this way we can figure it out how much blocks of water this building, or let's say the ith building, is going to store. I hope you got this. Now after getting all these values, after getting all the number of blocks that building is going to store, we have to sum it all, right? So summation when I will be running from 0 and it will be going to n minus 1. Now minimum of max left comma max right. After finding the minimum of them, we have to subtract it with the height of the building. That's it. So the pseudocode will look like this. First of all, answer will be 0. Now we have to run for each and every building. So I will be running from 0 and it will be gone till n, right? After that we have to find out the max left as well as max right. So max left, let's take it as minus infinity, because we have to find the maximum of it. Max right also minus infinity. Now we have to run two for loops which I have shown earlier. K is equals to I minus 1 and it will be gone till 0. Here we have to find out the max left. So math dot max max left comma a of k. With this we are going to figure it out that what is the maximum height of the building on its left. Similarly, for k is equals to I plus 1 to n minus 1, max right is equals to math dot max max right comma a of k. Now using this for loop we are going to figure it out that what is the maximum height of the building on its right. After finding max left and max right, it will be simple. Now answer plus equals to mat dot min is equals to max left comma max right and subtracting height of I. That's it. So using this pseudocode we will be able to figure it out how much water will be going to trapped. Simply return answer. Okay, so this is nothing but this only. Okay, so this is the first approach, or we can say the brute force approach. Now let's talk about the time complexity. Here we can see that this is the outer for loop which actually runs for the end time. Here also there is inner for loop which is also running for approximate to order of n, both of them, right? So the time complexity will be order of n square and the space complexity will be order of 1 because we didn't take any extra space. So this is the time complexity as well as space complexity. Now the interviewer will not be happy for this time complexity, so he or she will say to optimize it. So approach 2. Now again, as I said earlier, the optimization will only happen on the basis of observation, that how we are going to observe the problem. Now we can see that this pseudocode is actually running for the time complexity is taking is order of n square. Now due to these two for loops, it is n square. right? If we neglect this, it will be simply order of n, right? Now let's say that how we can eliminate these for loops. Let's say if we store somewhere, let's say in the array, for every ith building, the max left and its max right, right? So we can simply call that array here, or let's say access that array here. So due to this, this for loop will eliminate, right? We can see that for every ith building we are going on its left side as well as right side, for this, for this, for this, and for this. So due to that, the time complexity is increasing, it is leading to n square. If we eliminate these two for loops, it will be n only, right? Now this can be achieved using the prefix sum technique. So actually we are not calculating the sum, we are actually calculating the max left and its max right. So let's name it as prefix as well as suffix. Let's find the left max first and then right max. Now starting from 0th index, here we can see that the highest building till this point is 0 only. If you talk about this building, now we found the greater, now we found a building which has highest height, so this will be 1. Till this point on its left the highest is 1. Till this point we found out the highest building is 2, right? Till this point the highest building is 2. Till this point 2, 2. Now at this point the highest building is 3 now, right? So 3. For this it will be 3. For this it will be 3. For this 3. And for this also 3, right? So this is nothing but an array which we are going to store. So in the previous approach, for every ith building we were actually finding out the left max as well as the right max. But here we can see that in the one shot only, in order of n, we figure it out for every building what is the highest height of the building on its left. Similarly, we have to find out for the right. So let's name it as right max. Now similarly, we have to come from the right hand side. So from this, now till this point the height of the building is 1. If we come at this point, the height of the building will be 2, because till this point the height of the highest building is 2, right? If you come here, the height of the building on its right side is 2. For this it will be 2. For this it will be 3, right? It's obvious. Now similarly we can see that if you go forward, the height on the right side of the building will be 3 only, right? So we will be simply going to write 3 for all, right? So here also we figure it out, the highest height of the building on its right in order of n time, right? Now let's say for this building, we know the highest height of the building on its left is 2 and the highest height of the building on its right is 3. So we have to find the minimum of them, which will be 2, right? Which will be 2, and we have to subtract it with the height of the building, which is 0. So 2 blocks of water is going to trap. So in this way we are going to figure it out. So first of all, let's create the left max and right max array. Left max of 0 will be a of 0, right? We have seen this. First of all, we are going to create the left max, and the first value will be 0 itself, or let's say the height of the 0th element. Now for loop I will be running from 1 and it will be going till n. Now left max of I is equals to math dot max a of I, comma, left max of I minus 1, which is simple, right? I hope you know that how to find the prefix sum. Using that prefix sum technique only, we have derived how to find the max sum, sorry, left max as well as right max. So using this for loop, we will be creating this left max array. Similarly, let's create the right max array. So right max n minus 1 will be a of n minus 1, because on the right, let's talk about this. On the right, there is no building. So till this point, this building will be going to be the maximum height on this right. So for loop, I will be running from n minus 2, right? And it will be gone till 0. Now, right max of I is equals to math dot max a of I, comma, right max of I plus 1. So using these two for loops, we are able to create these two arrays. Now, for I will be running from 0 and it will be gone till n. Here we have to find it out, height of the highest building on its left and height of the highest building on its right. So int minimum height. So it will be min of, let's, math dot min left max of I, comma, right max of I, right? After that, height. So it will be a of I. Now we have to subtract, right? So answer plus equals to minimum height minus actual height. And that's it, we are done. Now simply return answer. I hope you got this. So this statement is actually finding out that the minimum height of the left max of I as well as the right max of I, and I hope you know that what is this, right? Now int height a of I, now this is nothing but a actual extra time only written because of the readability. So this is nothing but the current height of the building. Now what we are going to do, we are actually subtracting actual height of the building from the left max or right max, minimum of left max as well as right max, right? So this is what I've done. Now let's talk about the time complexity. Here we can see that we have used 3 for loops, but all are not dependent on each other, right? And all of them are actually running for n time. So the time complexity will be order of n, but we can see that here we have taken the help of the extra space, left max as well as right max. So it will be 2n, but it boils down to order of n. So the time complexity we have reduced, but we have actually taken the help of space. So due to that, the interviewer will not be happy for this. So there is another approach 3. So using that, the time complexity will be order of n and the space complexity will be order of 1. So in the next lecture, I'm going to show you this approach 3. So that's it from my side. I'll see you in the next video. Till then, keep practicing. Thank you.